Video we're going to take a different point of view on the derivative. So in a previous video we looked at y equals x squared and we found the slope of the graph at x equal to 3. And so that was the idea, is we want to find out, what is it going to take to have the tangent line at a certain point and so on. However, what if the next day we come along and we want to find the tangent line at x equal to 4, and the next day x equals 5, and the next day x equals 13. So what if we want to keep finding tangent lines at different points? We'd have to go through the whole calculation over and over and over again. What we're going to see in this section, though, is there's a way to do the calculation a single time, and then it will give you the answer for whatever point you are interested in. So you just have to do one calculation once, and you get all the answers you could desire there. So the idea is, instead of doing the slope calculations at a particular point, you're going to do it at a random point x, and then x can be plugged in for whatever you want later on. So how is this going to work? So remember, in the last time we said f prime of a was the limit as h goes to 0 of f of a plus h minus f of a over to h. That was the second formula that would work here. But we're now going to just change that a from a specific number to a variable here. And so it's going to be f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. And this is what we're going to use to find the derivative of any function we are given. And so let's go ahead and give an example here. We'll start with a little bit more complicated of a parabola. So let's say find the derivative of f of x is 3x squared plus 5x minus 7. And so we're going to go ahead and say, okay, f prime of x is the limit as h goes to 0, f of x plus h minus f of x over to 8 over h. And then we're going to do the limit as h goes to 0. So now we need to take our function, and everywhere we see x, replace it with x plus h. And it's going to get a bit messy here. So 3x plus h squared plus 5x plus h minus 7. And then we're going to subtract the original function, being careful that we are going to put parentheses here because I'm subtracting the whole thing, all over h. And then at this point we're going to do some messy algebra. We're going to go ahead and FOIL and distribute here. So first one, x plus h squared is x squared plus 2xh plus h squared. Then you just distribute the 3 here. And then we distribute the 5x plus 5h minus 7. Then I'll distribute the negative sign here. Now when you're doing these problems, as a general rule, you're going to have some things cancel. So I have a 3x squared, cancels 3x squared. 5x minus 5x minus 7 plus 7. Those are all going to cancel out there. What I will then have left is 6xh plus 3h squared plus 5h, and that's it, over h. Now you should notice that everything on top has an h in common. In fact, if it didn't, that would mean you did something wrong here, because the h is always going to be able to cancel. And again, if it doesn't cancel, you're doing your algebra wrong somewhere. And it has to cancel because we can't plug in 0 on the denominator. So if that h is still there in the denominator, then it's not going to work. We need to actually cancel it out. And once we do that, we're going to get something that we can plug in h is 0. and we get our final answer here, 6x plus 5. So that means the derivative of this function is 6x plus 5. And now that you have this formula, if you want to find the slope at x equal to 3, or x equal to 4, or x equal to 27 million, whatever x value you want, you just plug it in there, and that will tell you the slope at that point. So we do one harder calculation at the beginning, and it will allow us to get the slope at any point as we go through the problem. Now, anytime you have a polynomial function, it's going to work out similar to this, where you FOIL out and combine like terms and so on. However, there are going to be 3 total variations on this problem. The first is polynomial. The second is going to be a rational function. So let's find the derivative of f of x is 1 over 2x minus 3. Now, before I finish this problem here, I do want to point out that if you've seen calculus before, you may know some shortcuts to try to find these derivatives. However, at this point in time, we have not officially learned those shortcuts, so you cannot use them. But once we do learn them, then you will be free to use them from then on. Just wanted to keep in mind in case you happen to know some knowledge that other people don't. So we go ahead and plug in our x plus h here. And then we subtract our original function over h. Now, this is going to be more annoying algebra. First, I'll distribute the 2 there. And then this is what's called a complex fraction, where you have fraction on top, fraction on the bottom. So we're going to go ahead and multiply top and bottom by the LCD to get rid of the fractions. And then when we distribute on top here, we would have 2x minus 3 minus the quantity 2x plus 2h minus 3 over h times this previous common denominator here. And then when you distribute your negative sign in, the 2x's are going to cancel, the 3's are going to cancel, and the numerator is going to end up being just minus 2h. And as I promised you, the h's are going to cancel out. And we're going to have the limit as h goes to 0 of negative 2 over 2x plus 2h minus 3, 2x minus 3. And finally, we can plug in h equal to 0. And it's going to work out to be this right here. So again, as you can see, the algebra gets pretty annoying on some of these problems. But if you follow the steps, it will work out. The third variation of this is when you have a square root function. So let's find the derivative of f of x is the square root of x plus 3. It's the same process, just slightly different algebra that you have to worry about. For example, I cannot multiply by a common denominator here to cancel it out. I can't FOIL to simplify terms here. Turns out the only way you can do this is to multiply top and bottom by the conjugate, that other random thing you learned in algebra class. And then I'm going to skip a little bit of work here, but I'll leave it to you to show it all out. So if you FOIL out on top there, remember if you have a minus b times a plus b, it becomes a squared minus b squared. So you're going to have x plus h plus 3 minus x plus 3. And then the denominator is going to have the original h and then this conjugate that you multiplied by. And then when you distribute the negative sign in, you're going to have some cancellations, as we expected to have. And then the h is going to cancel because it has to. And if I plug in h equal to 0 here, it's going to work out to be the following. Now, obviously, there are other functions out there than just polynomials, fractions, and radicals. We have trig functions, exponential functions, and lots of other things. However, those get even more complicated, and we're going to just not worry about them for now. Just keep that in mind that they could be out there, but not in this section here.